Hi, welcome back to Mr. Slover's Math. Today we're going to focus on solving multi-step equations. Now the good news is we actually did this first semester, so it should be pretty familiar, but I am just reiterating how to solve multi-step equations since we are doing solving in this unit and you're going to use it later in your mathematical career. So it's good to practice. So number one is just asking you to solve either a one or two step equation. Letter A is just a one step. I divide both sides by 3. Letter B is a two step, so I subtract the 5 and then make sure that this is really saying negative x. So you could rewrite it as negative 1 times x, and that's why I'm dividing by negative 1. So x is 2. And as always, you can always take any of these solutions and plug it back in. If I take 2 and plug it in, negative 2 plus 5, I get 3, and that's what I wanted. And then letter C, you may see ones in today's notes where you have to collect like terms. So m minus 12m, they're on the same side of the equal sign. They are like terms, right? Same variable and same power. So I just add or subtract. So I end up with a negative 11m equals 33 divided by negative 11, and I get m is negative 3. So that's just to get our mind thinking about solving. So example 1 is solve the following equations, round to the nearest tenth. So letter A, I've got some like terms, same letter, same power, so I can combine them. 2x plus 3x is 5x. I divide by 5. Now notice I wrote my answer two different ways. I have negative 1 equals x, because if I solve with the way that it was printed, I would get negative 1 equals x. Some of you are like, well, Mr. Slover, negative 1 equals x doesn't make sense to me. Can I just rewrite it as x equals negative 1? Yes, they're the same thing. Okay, so it doesn't matter. Letter B is just a straightforward two-step equation. Letter C and D is where I'm upping the complexity. So now I have variables on both sides of the equal sign. So drawing in that line may be beneficial here. So we get back into the swing of solving multi-step equations. And the purpose of that line, once again, is for you to realize that the negative x and the negative 3x are not on the same side of the equal sign. You cannot combine them right now. Okay? But what I do need to do is to get all of the variables on one side. So in order to do that, I have to do the inverse operation. So currently, I'm choosing to get my variables on the left side. And right now it says I have 11 minus 3x. So I'm subtracting here. So the opposite or the inverse of subtraction is addition. I'm going to add 3x to both sides. So this is negative 1x plus 3x. So negative 1 plus 3 is the 2x. The 1 stayed the same, the equal sign is the same, and the 11 is the same. Now I've got all my variables on one side. Let's get the constants, thing without the letters, on the other side. So I subtract 1, and then I got variable one side, constant other side, divide by 2. Right? And I'm dividing by 2 because it says 2 times x. I'm doing the inverse operation of multiplication, which is division. Letter D is the same concept. I have variables on both sides. Now, it doesn't really matter which side your variables go on, whether you solve and get them on the left or on the right. But I will caution you, if I subtract 3n, then I don't have anything over here. Okay? And that's okay. It would be a 0. But just be mindful that sometimes it's easier to have them on one side versus the other, even though it really doesn't matter. So I'm going to choose to get them on the left. I'm going to subtract 7n from both sides, and I get the negative 4n. And that's okay. There's nothing wrong with that negative. Then I'm going to bring down the equals to negative 8. I divide by negative 4, and n is 2. Once again, for all of these, I can take my solution and plug it into my equation to see if it makes it true. So 3 times n, or 3 times 2, is 6. So now I'm going to see if that works on the other side. Negative 8 plus 7 times 2. Well, 7 times 2 is 14. So if I do negative 8 plus 14, I get 6. Well, that's the same thing that I had on the other side. So 6 equals 6 is a true statement. so I know I did the problem correctly. Example 2, there are 6 of them. Now some of them I have added. Sorry, I don't know what happened. Okay, so let's try this again. I don't know what happened there. But on example 2, some of them have parentheses. Not all of them, but some of them do. If I have parentheses, I need to get rid of them, and that's where I need to distribute. And that's why I have a note over here that says distribute first. So in letter A, I showed what I was doing. -3 times -7, that's how I got the 21. And -3 times 3x, that's how I got the -9x. Yeah, you don't necessarily have to show that step, but I wanted you to be aware of where everything came from. Okay. So I distributed, then just like before, I want to get all the variables on one side and get all the constants or the numbers on another side. So I'm subtract 21 from both sides. I'm going to divide by -9, and I get x equals -7. So example 2, these are a little bit more complex only because I have to distribute and I might have higher numbers. Like I have 366. But the process is still the same. Okay? Distribute, get all your variables on one side, get your constants on the other, and solve. Okay? So the process is the same on all of these. So if you have any questions, make sure you stop in and let me know. But otherwise, today we were just focusing on solving equations. Okay? You got to do the inverse operations of everything. So thanks for stopping in. Until next time.